This game is the Labyrinth game. It consists of a flat surface maze with the objective of getting the ball through the maze. The design of this project involves the focus on the device being able to sense, think, and act. The maze will sense the user's control, process the user's inputs to convert them to outputs and tilt the maze forward. There are two stepper motors with stepper motor drivers attached to each. Each motor functions for each axis as a pitch and roll. With the motor drivers, there's a power source for the large current requirements for the motors. The functioning of the motors are programmed into an Arduino microcontroller. The functionality is based on a PWM for the configurations for the stub motor and transmitting the controller. The transmitting controller, in simplistic terms, is just a joystick potentiometer with two analog outputs for both of the axes. We have two magnets along with one Hall effect sensor for each axis in order to limit the functions of the motor to stop it from overturning the board. Also, there's an XT60 capacitor lead that allows for easy connections for the DC signal for the entire board.
Overall, our print took a few days to make and it ended up being pretty average to fit everything. However, we have two bearings that can control the axes and keep them in line, along with some rods to stop them from moving down on each other. And along with that, we've got two motors on the sides that can turn each axis, one motor for one way.
And then kind of on the circuit hardware side, you can see that our signal comes in through the receiver. You can see the pitch and roll channels changing here. You can see when we enable it, that goes high, then low when it's disenabled. That goes over wirelessly, gets received normally from the receiver. You can see our receiver quit working spontaneously, hence why the entire system is being controlled by Ryan here. So normally that signal would be received on the receiver. The three channels, the activate and the pitch and roll, go on these white wires, which then go to the Arduino. The Arduino does the code and thinks about it, and then it reacts by sending out four outputs. Those four outputs being a step and direction for the first stepper motor driver, which is on the other side here, and then the step and direction for the second stepper motor driver, which is on the other side here. The only other components in the system are voltage regulators, which you can see on the other side, as well as passive components such as electrolytic capacitors and resistors. The system also utilizes Hall effect sensors to know when the board has reached its limits. Again, this all worked, but on Expo Day, the receiver kind of died last minute, so we're unable to kind of show the completed project working.